Hello everyone, good evening.
Yes, sir.
Okay, so today we have solved with a session for week 8. So how many of you have covered week 8 content? How many of you have gone through the lectures which are available in week 8 content? Conditional probability based theorem.
Yeah, I have gone through, but still not completely clear. I still need to go through once again.
Okay, so like how are you finding the probability thing? It started in week 7, right? So how much you are comfortable with probability by now? It's been 2 weeks now.
Yeah, probability for me, yeah, that was it's okay. It was I was clear. Week 8 is little bit. The only thing is that converting the problems into the finding out the events. That is some of the issue I'm facing.
Mhm.
Yeah, like events, like before events, like the given thing, like something like a event giving. Given event. So that thing. Sometimes it's kind of confusing, but yeah.
Okay, so we will try to cover it in today's sessions. Okay, so before that, can you all please go to joinpd.com and enter the code shown on your screen? Okay, so yeah, I think most of you are now by now aware of the instructions, right? So keep a notebook and pen along with you to solve the question. You will see the questions on your screen, and to answer them, you can answer them on joinpd.com. You have already entered the code which is shown on the right top of your screen now, which is RRKFWZ. For every question, you will be given some time to solve and input your answer. Please don't type your answer in the chat. You just input it over in joinpd.com so we can discuss it later. So if you're using it on laptop or desktop, your view would be as shown in the left side of your screen now. And if you are using it on mobile, your view would be as shown in the right side of your screen. For mobile users, you have to click on the option answer question and then input your answer, while desktop or laptop user can input it side by side. Okay, so we will start with some basic probability question for now. So it's like simple question. We have an urn which contains 5 blue balls and 8 red balls, and I'm just drawing one ball at random. So what is the probability that drawn ball would be red?
Excuse me. Hello.
Yes, please.
Can you please share the key? Oh, somebody shared on the chat. Thank you.
Okay, so have you all solved it, or do you guys need more time for this?
Sir.
Done, right? Okay.
So done.
Okay, so moving to solution part. So how did you guys approach this one?
Sure, normal favorable cases like 50 cases. So 8 red balls are there, and the total number of balls are 13. So it's 8C1 divided by 13C1, or basically like 8 by 13 normally.
Okay, that's correct. And another way could be like, if you go by basic probability we studied in class 10th to 12th. So
Yes, sir.
total number of like total number of total ways could be 13, and number of favorable outcomes are only 8, right? That 8C1 is just 8. So it's simple, right? It's 8 over 13, which you can easily compute. It's 0.62. Okay. Now let's increase, like, modify the context of this question now. So we know that I'm drawing a ball, it turns out to be right? Now second person came, say, okay, and he knows that there was in total 13 balls, 5 blue balls, 8 red balls, and he knows that the first ball drawn is red. So what are the chances that the second ball would be blue? You got the question context, right? I have drawn a ball, it comes out to be red. Now the second person came and he noticed that there were initially 13 balls, 5 blue, 8 red. He noticed that I have already drawn a red ball. So what are the chances that he will get the blue ball now? Okay, so before moving to solution part, just a general question, like if you already know that one red ball is already been drawn from the sun, would it affect the probability of you drawing the blue ball?
Yes, sir. Since the replacement is not allowed, so
Mhm.
so one ball would be less. I mean, the total outcome is now from 13 to 12.
Okay, so knowing this information would increase your chances of drawing blue ball, or would it be same, or would it be less?
It would
Increase
less.
the chance of drawing.
Increase, yeah.
Okay, so suppose I haven't drawn any ball. Okay, so initially the chances of drawing blue ball would be 5/13, right?
Yes, sir.
But given this information that one ball is already been drawn and it is red, right? In that case, we get the increase in the chances of blue ball being drawn in the second drawn, right? It would
Yes,
be
sir.
now 5/12
Yes, sir.
instead.
Yes, sir.
So that's how,
Yeah.
if we have some additional information, our probability gets changed. So if I said what are the chances of drawing red ball in second draw, it would reduce, right? Because we know that one red ball is already been drawn in the first draw, right? Okay, so yeah, so that's where the conditional probability comes in. So but so, okay, so we're not going to conditional probability now. So what is the probability that the first ball is red and the second ball is blue? So for first ball is red, we know it's gonna be 8/13, right? And second ball being blue is just 5/12, right? So it is nothing but just the intersection of two events, or in general, you can say multiplication rule coming into play, because we know that the first ball is red, it's let's say event R, and the second ball being blue, given first event R has already occurred, will be my drawing the second ball being blue, right? Any doubt in this, or is it clear till now?
If we minus the red ball probability,
Minus the red ball probability means,
and means previous question we get the probability of outcome of red ball,
yeah,
and here its answer is point something 62. If we minus this, if we minus this probability, then we will get the answer of the probability of blue ball.
no, that's not the way. So the question is you get, okay, so the question statement here is, what is the probability that first ball is red and then second ball is blue, right? So it is basically the intersection of two events. The first event is drawing a red ball and second event is drawing a blue ball, right?
Right.
So it is the intersection of two events, R and B. R and B means R intersection B, right? Then we can use multiplication rule, right? So first ball being red is probability of event R, right? And now second ball being blue, given that first ball is red, it's probability B given R, right? So in
Yes.
B given R, we have only 12 total outcomes, and my favorable are all those 5 blue balls. That's why it's 5/12.
Okay. So got it.
Sir, if we think about this question in other way, that in this question we have chosen that we have replaced the first ball, and then we take the probability of blue ball. But in but in another scenario, if we choose both the balls simultaneously,
Yeah, that's also without replacement. Simultaneous selection
okay,
is also.
then also add -1.
Yeah.
Okay, sir.
If it's with replacement, it would be mentioned in the question statement.
Okay, sir.
Okay, so that's something a bit interesting question. So suppose you are writing an exam and probability of you passing the section 1 is 0.8 and passing the section 2 is 0.9. So what is the probability that you will pass both the sections? Okay, so for now, let's assume it's one subject paper you are giving in which you have two sections. Okay, so how would you approach this question? How would you approach this one?
That is the intersection between both the probability.
Okay.
So just
They
multiply
are
the
independent event.
I follow the previous approach which you have told.
Previous approach. Okay, so how? Okay, let me just share the whiteboard. So okay, let's say we have two events, right? Let's say S1 is that one will pass section 1, right? And S2B that one will pass section 2. And we have to find probability that we pass both, right? I'm not wrong. So how would we find this?
Probability of S1 times probability of S2 given S1.
Okay. And what are these probabilities?
Probability of S1 will be 0.8 and probability of S2 given S1 will also be 0.9 because S1 will not affect probability of S2.
Is it given?
It is not given, but by language it should be like this.
So we know that individually, okay, we know individually that probability of passing section 1 is 0.8, if I'm not wrong. Probability of passing section 2 it's 0.9. But do we know this probability?
We do not know, but we assume that section 1 and section 2 should be independent.
But it's not given, right?
So it is not given.
So we cannot find the second part, right? Right. We know individually that passing section 2 it's 0.9, but we don't know whether passing section 1 would affect this probability or not, right? This information is not given to us. Like in the first
Excuse me, sir.
question. Yeah.
Sir, what I understand is like in that it is not, I mean, not mentioned like if they are dependent on each other. I assume that if it is not mentioned, that means it is independent event because they have asked like section 1 and section 2,
Mhm.
right? So they will be independent event. So we have to simply multiply it, A intersection B. And if they are independent, then P of A multiply by P of B.
No, but that's my point, right? We don't know whether passing section 1 is affecting my result of section 2 or not, right? Like in the first question.
It is not
no-
mentioned. That's why we can assume
Sir,
that they are
no, no,
let's
independent.
Okay, let's assume that they make sense. But if there is subject, suppose mathematics and science, so then also we will say insufficient information.
Yeah. You see,
Uh,
even if in this degree, right? So one performing good in, let's say, mathematics should also perform good in CTO statistics because these subjects might be in some sense interlinked, right? So
So if math and history are there, then we will say 0.72.
yeah, if it's independent, then it would be 0.72, right? But here we don't know whether it's vecting or not. Like in the first question, we know that drawing the red ball has increased the probability of blue ball in second draw, right? So it might be possible that passing section 1 might increase the probability of passing section 2 or might even reduce the probability of section 2, right? We don't know this information over here.
So,
And it
so
also
throughout this course, we will consider dependent unless it is not mentioned.
not always. Sometimes it might be clear to you with the question statement, but sometimes it's necessary to be mentioned unless we cannot consider it to be independent.
But here
So,
in this question, probably every student understand that it should be independent, sir. How
yeah, but
we can
that's
distinguish?
why this question was put it in slides because you shouldn't understand that these are independent unless and until specified or it's very obviously clear from the question statement. Okay. So here this second information is not known to us, so we cannot say whether we cannot compute that probability in general. So it would be insufficient information for this case. But if I modify this question a bit, if I add one more statement that the event of passing section 1 and section 2 are independent, now you can, okay, now we know that it's independent, now we have enough information to solve it. Okay,
Okay, sir.
I think now we can quickly
And sir, what I told previously, if math and history is their subject, then it should not be mentioned that whether independent or not, right?
Yeah, in some sense, yeah, you can assume. So yeah, in some sense, it would be like the statement you made, math and history, right? In some sense, it
Yes.
would be very clear to you that these are independent, but in some, it's necessary that it should be mentioned.
Okay, sir.
Just quick 30 second. I think most of you have already solved this one.
We can think about this question rather than section 1 and section 2 as term 1 and term 2. You can only qualify term 2 if you qualify term 1. Can we think like that?
Like it would be like a bit different question statement, but before, like while reading out the question, I told you that assume that it is a single subject which has two sections going on. So section 1 and section 2 might play some role. Question statement would be like give you a better idea
Okay.
how to proceed further. Okay, so now we can compute as we know that we have all the information over here. Okay, so let's move on to next one. So suppose there are 45% of female and 50% of male in our given population. And among all the females, you know, there are 9% of left-handed. And among all the males, there are 11% who are left-handed. So if you randomly choose a person from this population, what is the probability that person is right-handed or in general not left-handed? Leave it at that. Okay, so do you guys need?
Sir, can you give 30 seconds more, please?
Okay.
Thank you.
Okay. Do you need more time or able to solve it? Shall we move to solution part?
Yes, sir.
Yes, sir.
So what is the given information to us? Okay, let us define the event like that the selected person is female, right? We could have this, or selected person is male, or selected person is, let's say, left-handed, and one more event, let's say that selected person is not left-handed or right-handed, right? Okay, so what would be the probability of selecting a female?
0.45. 0.45.
0.45. What about probability of selecting a male?
0.55. 0.55.
Okay. Probability of selecting a left-handed? Do we know this?
0.0.
No,
Right,
no,
no?
sir. We don't know.
Sir, 0.45 times 0.09 plus 0.55 times 0.11.
Let me just do this. So this is my complete population. Okay. My complete, let's say, population. Okay. I can split it into two parts, right? So this 45% is females and remaining 55% is males, right? And
Yeah.
let's say these are my left-handed people. This blue circle, right? So to find how many are left-handed, or the information which I need is to find this region and this region, right? Okay. So what is the orange region?
Sir, 11%
Probability
of
of
11% of
female
55%.
left-handed.
What is this orange region? What does this orange region specify over here?
Female left-handed.
It is 9% of 45 female.
They are left-handed females.
Yeah, left-handed females, right? This orange region is nothing but intersection of L and F, right? Right? Females. Okay, so let me just calculate a bit. Suppose this green region is my female region. So intersection of female and this blue circle would be this orange region, right? So this orange region is nothing but intersection of left-handed people and female, right? So can we find it like this by using multiplication rule? Can I write this intersection as this?
Yes, sir. Why not?
Okay, but what about this L given F? Do I know this information? L given F. Probability of female, I
We
know
know.
this. Okay. From which statement we know this? From which statement you know this?
So 9% of female are left-handed.
9% of females are left-handed. It means given females, the probability of being left-handed is 9%, right? So that's where this L given F comes into.
Sir, there
Yeah.
is some lag between switching the windows, sir. Why not you share your whole screen, sir, so that no lag?
Okay. Is it visible?
So now visible, sir.
Visible, right? Okay. Okay. Now what about yellow region? Yellow region is, how can I write this yellow region in terms of events, in terms of these 4 events?
Male and left-handed.
L intersection M, right? It's the intersection of male and this blue circle, right? So again, we can use multiplication rule in similar manner and find this probability, right? We know probability of male is 0.55. Do we know this L intersection M? 111, right? Because among all the males, there are only 11% left-handed, right? So we can solve for this one. So my final goal was to find that the selected person is not left-handed, right? Or the selected person is right-handed. It means 1 minus probability of selecting a left-handed person, right?
Yes, sir.
Yeah.
And left-handed person is nothing but the addition of this orange region and yellow region in my plot.
Yes, sir.
Orange region is, I can write like probability of L intersection F, and yellow region is L intersection M. So we have computed this probability. We can subtract it from 1 and get the desired result, right?
Yes, sir, but we can also do without formula, sir, by assuming that there are 100 people.
Yeah,
or
you can do like that also.
Yes, sir, I've done like that.
Sir, it's like a column related frequency. Like, see?
If you want to do the contingency table, yeah, you can approach like that and find out that.
Got it.
Okay. So if you do this, it would come out to be something 0.899. Okay. I hope you can solve it by, like, we have already plugged in the values. You can do the calculation part and check. Any doubts till now?
Sir, just
Yeah.
one question, sir. So the given probability that we had over there, so before multiplying, could we just subtract that from -1? I don't know if that's a correct way to do it. I mean, the given probability that L given M, L given F.
Okay, you want
Could
to
we
find
just
R given M.
no, sir. The before multiplication, I mean, we know the probability of male and female, right? I mean, how many are they? And we are multiplying with the that 11% thing and 9% thing. That I totally understood. But could we just subtract that 0.11 from
Mhm.
1 and then subtracting 0.09 from 1 and then multiplying with corresponding values?
Mhm.
So could we just approach that way as well?
Yeah, in that way you will directly get the probability of L complement.
Because
Yeah.
I did the same way, so I didn't know if that's a correct correct way to approach that.
That's correct. You can approach like that.
Okay, sir. Okay, thank you.
Okay, so we know that what's the probability that the randomly selected person is not left-handed, but also we know what's the probability that selected person is left-handed also, right? So again, the same information given to you, but one additional information is we know that the person is left-handed. Then what is the probability that the person is the male? So you know that the selected one is a left-handed. You need to find out the probability that the selected one is male now. Okay.
Mm.
Okay, so do you guys need more time in this? Or is it done, right? Okay, so how did you approach this one?
Sir, we are given that the person is left-handed, then we need to find the probability that he is a male. Means we need to find the probability of male given left-handed.
Yeah, male given left-handed, right? So male given left-handed means to find this you need the probability of being left-handed and probability of male intersection left-handed, right?
Yes, sir.
So do we have those probabilities?
Yeah.
Yes, right? We have just computed it in
Yeah.
the previous part. So just plugging in it, we got this. So it is an example of Bayes theorem coming into play, where your denominator you can find using law of total probability, which we just discussed using that Venn diagram, right? Yeah.
Sir, how do we know that is Bayes theorem apply or simple M intersection L is used?
It basically at the end of both of these, like you are using only conditional probability, right?
Sir?
The name given based on which events you are finding. So it's okay as long as you stick with one formula and compute the probabilities. It's completely fine. Yeah. Any doubt in this? Anyone?
Sir, Bayes theorem I could not understood clearly. Could we solve all question without Bayes theorem?
Bayes theorem is used in this question, but we haven't, specified that Bayes theorem is being used or something, right? We simply solved
Sir,
it like
Bayes,
conditional probability.
Means what I am saying that Bayes theorem I could not understand clearly. Will all question will be solved without Bayes theorem? Is it possible if we understand all other?
A Bayes theorem is just a specific name given to, okay, so here what we are known is, so we know some characteristic, right? We know that it is the selected person is left-handed, right? We know it. This event has already occurred. Okay,
Yes,
now
sir.
let me give you one. Let me give you one example. We'll go with some easy, simple example. Okay. Okay. So you know about machine learning, right? Are you aware of what is machine learning?
It's a heart of the term. Don't know about
Machine
it.
learning. No, sir, we do not aware clearly.
Okay. So have you ever heard about any machine learning model or something?
Sir, I think I have heard a neural network, something like that,
Okay.
where we
So
give
you're
weight.
aware of. Okay. Okay. So let's suppose I had some 100 images, right? Let's assume I have 100 images. Okay. And
Yes,
you
sir.
know that you have built a model so such that it will predict the it will predict cat with probability 0.7. Okay. Predict dog with probability 0.2 and lion with probability 0.1. Okay, 100 images of cat you have, right? So if you show image to that image of that cat to your model, it will either predict cat, dog, or lion, and these are the probability of it predicting, right? So
Correct prediction, right?
not correct prediction. If you have 100 images of cat, right? You show any image to that model, these are the chances of model predicting cat, dog, and lion
Okay.
by visualizing that image. So okay, so this is conditional probability, right? So you have shown the image of cat, right? And you are interested in the probability that it has correctly predicted cat, right? So it is 0.7, right? It has predicted dog given cat image, it's 0.2, and similarly given cat. Yeah,
Sir, that is 0.7 or 0.1?
this is 0.7 and last one is 0.1.
Okay.
Okay, now let's modify this question a bit. Suppose let's say you have okay. So now suppose I have another bundle of 50 images of dog, let's say. So let's say 50 images of lion I have, and I have some distribution of it predicting lion probabilities. It predict lion with this probability, cat with this probability, and dog with this probability, right? It's possible to have, right? So
Yes, sir.
let's suppose now you know that your model has predicted that it is cat. Now we know the final result. Model has predicted the cat, right? Now we are talking about previous step. The previous step would be I have shown the image to the model, right? So what is the probability that image shown was of cat, given that the final prediction is cat? So that's where we use Bayes theorem. Knowing the final result, we are talking about previous steps. And here it's conditional probability. Knowing the first step, we are asking what would be the result. Right? First step would be showing the cat image. And then we are predicting what would be our result. But in Bayes theorem, we know the result. We are predicting about the earlier steps. What was the step?
Okay, if we know the conditional probability means we can build that Bayes theorem equation, right?
Yeah, you can simply, it's the same thing, right? Cat image intersection cat. It's the same conditional probability formula. But the reason we call it Bayes theorem is because of this. Like knowing the final result, we predict the earlier steps.
Okay, to give respect to the scientist.
Yeah, so Bayes theorem would be used a lot in your machine learning courses in diploma level. So Bayes theorem is something you need to get a grip on over here. Even in stats
Okay,
too, it
sir.
would be used. Okay.
So this is divided with the weighted probability of each individual cases, right, sir? So that total weight will be always 1.
Yeah. Okay. Let me just add one more. I don't know if this was covered earlier. Let me just do it. Okay. So you know what is a sample space, right? Sample space is set of all possible outcomes, right? Right. So let's say my experiment is tossing 2 coins. So my possible outcomes are this. Okay. Let's say my event A is getting 2 heads. So what is the probability of A?
1/4.
0.25.
Yeah, 0.25. Okay.
0.25.
Okay. Let me define another event. Let's say event B, that getting heads in first toss. What is the probability of B?
1/2.
1/2. 0.5.
Yeah.
Okay. So in general, okay. Now what is the probability? So how do you interpret probability of A given B? What is the interpretation of this A given B?
We are getting head when getting head on second toss when we get head on first after getting head on first toss.
Getting two heads, given that you got
One head already occurred.
head in first toss, right?
One head in first toss.
You got head in first toss. Okay. So what happens when I got head in first toss? Did my sample space change now?
Yes, sir, change.
Yes.
What is my new sample space now?
Head,
and
head,
Only
tail.
two. Only two.
Head and head tail, right?
Yes, sir.
So
The
if
second
you
toss difference.
So if you notice carefully, A given B is nothing but it's the probability of getting A with B as your sample space, right? This is my event B also.
Okay, sir.
So in general, whenever we write probability of A, it means probability of A given sample space S. We in general avoid this given S because it's assumed that this is our new sample space. So when I'm saying A given B, it means I'm not talking about my old sample space. Now my sample space is changed and now it is new sample space is event B now. So conditional probability just change your sample space, right?
Okay, means the conditional probability is actually more general statement than normal probability.
This A given B is again the probability telling you that you need to find the probability of A, but your sample space is now B. In general, we don't write this A given S because it is assumed that we have one sample space and we are finding probability of A. So A given S means I need to find probability of A knowing that S is my sample space. Probability of B knowing that S is my sample space. A given B, probability of A knowing that B is your sample space now. Is it clear?
Yes, sir. It is not clear. It is
Yes.
more clear, sir.
Excuse me, sir.
Yeah.
Sir, in the previous question, which we have to do, sir, we already know probability of M intersection L. So why we can't use that?
You can use that. Probability of M intersection L is the same, right? 0.55 into 0.11.
But sir, in that formula, there will be no 0.55 because M intersection L is 0.11.
M intersection L is not 0.11. It's L in given M is 0.11.
Sir, I'm saying about the conditional probability formula.
Okay. Let me do this one using this also. Okay. Okay. So we know that we had this male section and female section, right? Female section was 45%,
Yes.
male section was 55%, right?
Yeah.
Okay. So the statement was among all the males. So let me just mute all for background noise purpose. Among all the males, we have 11% of left-handers, right? Okay. So what does it mean? It means among all the males means I'm talking about only males. Now my new sample space is only males now, right? Getting a left-handed is 11% chances. or 0.11, right? Similarly, among all the females means my new sample is only female. Now I'm talking about only females. Getting a left-handed is 9%, 0.09. And you need to find the probability of a left-handed, right? So that's what we can do. We did it right, orange region and yellow region. You can go back on YouTube and check. But that's the interpretation. Among all the males means my new sample space is now males. Among all the females means my new sample space is now females. I'm talking about only best event of that sample space. No, I'm not considering my whole sample space. So condition probability just change your sample space main motive. It shortens your sample space.
Sir, in the question also main, I have to M given L.
In question you have to find M given L, yeah. But we know L given M.
Okay, sir.
These two are different things, right?
Sir, if we don't know about that.
Don't know about what?
If we sir not know what is L given M, then we can use the intersection M intersection L.
Yeah, then you would use that. Like some information would be provided for you to solve this.
Okay. Okay.
Okay, so I think that's the last question of the slide for today. So suppose a student appeared for an aptitude test of a company which has 3 sections. Okay. So these are some probabilities given that he will pass either section 1 and 2 or section 1 and 3. Okay. So individual probabilities of sections are also given to you as P 1/4 and 1/3. And you know that these events are independent. If passing any section is a independent event for now. You need to find the value of P if probability of passing the aptitude test is 1/3. So when will you pass the aptitude test? When you will either pass section 1 and 2 or pass the section 1 and 3. Like it's just like you need to pass the section 1 and among section 2 and 3 you have a choice. Whichever you want to put effort in, you need to pass these 2 sections.
Sir, I need more time. 1 more minute, maybe.
Sir, please improve, increase time.
Okay. So you guys need more time, or are you able to do it?
Yes, I need more time. Just calculating.
Last 3 minutes.
How much time will you give, sir?
Okay, shall we move to solution part now? We have spent a lot of time on this question.
Yes, sir.
Okay, so how did you approach this one? I think many of you haven't answered this. How did you approach this one?
The first find the intersection of S1 and S2, then S1 and S plus S1 and S3 minus intersection of all the three.
Minus. Okay, let me just write it down. Let's do it that way. Okay, so let's say event SIB that I pass the ith section, right? And my I goes from 1, 2, and 3, right? S1 is passing I first section, S2 would be passing second section, S3 would be passing third section, right? So what is the probability of S1? How much it
P,
is?
sir.
P, sir.
P. And S2?
1 by 4.
1 by 4. And S3?
1 by 3.
1 by 3. Okay. Okay. And it is given to us that probability of passing the aptitude test is 1 by 3, right?
Yes, sir.
Yes, sir.
One by 3. Okay. And when will I pass the aptitude test?
Either 1 and second or 1 and third.
If I pass section 1 and section 2, or I pass section 1 and section 3, right?
Yes, sir.
Okay. So, okay, for a moment, let's say S1 intersection S2 is your event E and S1 intersection S3 is your event F. So in general, I am finding probability of E union F, right?
Yes, sir.
What is
Excuse
probability
me,
of E union F?
sir.
Yeah.
But surely he can also pass if it's section 1, 2, and 3.
Section
Because
1, 2,
that's
and 3. Yeah. So if I say S1 intersection S2, it means it includes passing S3 and failing S3 also. It includes both of them, right? So
okay.
if you want to visualize, suppose this is your section 1. Let me just make it a bit clear. This is your section 1. This is your section 2, and this is your section 3, right? So change the color. This is section 1, section 2, section 3, right? So what would be your S1 intersection S2? It would be this part, right?
Yes, sir.
If I modify it a bit. Okay. So intersection of all three would be this, right? It means passing S1, S2, and S3, right? And this would mean passing S1 and S2 but failing S3. So if you take whole intersection of S1 and S2, it includes failing S3 and passing S3. So when I say S1 intersection S2, it means It doesn't matter whether you pass or fail in S3. We are only focused on passing these two. Okay. So E union F, I can write it as probability of E plus probability of F minus E intersection F, right? This is the formula of A union B, right?
Yes, sir.
So E is nothing but S1 intersection S2, right? And F is S1 intersection S3. What is E intersection F?
Intersection of all S1, S2, and S3.
All three, right? Okay. So, and we know that these events are independent now, right? So I can simply write it as probability of S1 times probability of S2 minus probability of S1, probability of S2, probability of S3. Okay, and we know this probability is equals 1 by 3, right?
Yes, sir.
So if I plug in the values, it's 1 by 3. I can take probability of S1 common from all these three terms, right?
Yes, sir. Yes, sir.
So it's P comes out, right? So probability of S2 is 1 over 4. S3 is 1 over 3 minus 1 over 12. I think you can solve and get the value of P now, right?
Yes, sir.
3 plus the 7, it would be 6 over 12. P would comes out to be something, if I'm not wrong, it's 2 by 3. I might have. Not sure. Okay. So that should be the approach here. Right? Yeah, that's how we did it. Yeah. So any doubt in these slides, anyone?
So can you
Sir,
go back?
Sir, one doubt is regarding course registration. It was mentioned that on 1st November we will get admission letter, but till now I did not get. Is it also with other person?
Write
We
the
don't get.
write the mail to support team. Okay, they will tell you.
Sir, I have written. Actually, I want to ask to all the student, is admission letter or document verified verification letter has come to anyone?
Not yet.
No, not yet.
No, not yet.
Okay, okay. Means it is under process.
Excuse me,
Any
sir.
doubt? Yeah.
Sir, can we go back to that question that we were discussing independent event or not independent, the exam, section 1, section 2? So somehow I'm still
Okay.
not convinced with that.
Okay. So
Yeah.
okay, recall the question 1, right? Question 1. So here drawing the red ball in the first draw affect the probability of drawing the blue ball in the second draw. Was there any effect?
So this is like something in 1-on-1 and it's like a blindfold. We are putting our hand and have to take out one. So obviously it will be dependent, right?
Okay, let's go with some simple examples in that case.
So can't we take the example of like a qualifier exam? We have different sections because I think it's a perception, like how we are taking the question. One can take the section like section 1 and section 2 of a mathematics exams, right?
Yeah. Okay.
And one where even if you score good in section 2 and you achieve the aggregate, you will pass the exam.
Okay.
And if you take the like qualifier exam, right, where you have to pass the exam individually, like
Okay.
all the subjects. So that's what I'm saying. Like it depends upon like how we perceive the question. So that question is not clear, I think.
Yeah, that's what
In the
question is.
exam, but we expect in the exam it should be clear, like what kind of section, what kind of exam it is. Is it like if it is specified, then we can think, because I think it is not an English exam, it's a maths exam. So like we expect that question should be more clear. Otherwise, we will simply lose the marks, even in the like where we can score, we will lose the exam. In the easy questions, we can easily score, right?
See, that's what your doubt is, right? We don't know whether it could be independent, it could be dependent, right? That's what your doubt is, right?
Yes.
Yeah. So that's why there was an option insufficient information.
Okay, so
That's
if it is like that, the information is not clear, then we simply choose this kind of question, this kind of option, you mean?
the question. Let's see.
Okay, fine. Then we'll see if something come like
Yeah,
this,
this is
then
insufficient information, right? So you are not clear whether they are independent, dependent. You cannot proceed further in this question while solving, right? So that's
but
what
yeah,
insufficient information.
yeah, I understand it's insufficient information, but somebody will perceive like it could be independent or independent.
See, that's what you need to identify, right? We cannot just by reading this, cannot say with certainty that these two are independent events.
Okay,
Unless and
so
until it is mentioned, right?
okay, and one more doubt I have in tutorial.
Okay.
In practice question, I mean in week 8 tutorial. 1 minute, I will tell you the number.
Sir, I have a doubt about the tutorial 4.
Okay.
Can you also help by addressing week 8 tutorial 7 questions? I'm unable to follow how the answer is.
No, don't go with the answer. How did you approach this one? So all of you might have possible to have a different approach and still get the correct answer. So,
but the answer, I'm not sure how the answer was derived. So is it possible to share the workings or so that we understand how the sum is solved? Because just giving the answer does not help, and I have no other way or means to understand how the solution is arrived at.
no, see, we have this. So how have you tried those questions on your own?
Yes, I've tried all the questions in week 8 tutorial 7.
Okay.
I was not able to solve them.
Okay, which question? Okay, let me just share my screen.
Questions 2 to questions till the end.
Tutorial
From
7.
onwards.
There is no tutorial 7.
Tutorial 7, yes, sir.
There is only 6 tutorials, right, in week 8?
Yes, sir, only total 6 tutorials.
Yeah.
Sir, I have a doubt in tutorial 5. I want to understand how that Venn diagram is made. I am not getting the Venn diagram.
Okay,
Sorry,
so
sir.
have you,
Activity question 7, not tutorials. Activity question 7, sir.
Okay, we will come to that. So have you tried drawing this Venn diagram on your own?
Yes, sir, but it is not, I mean, I'm not getting it's something different. I mean, it's not the regular one.
Okay, so let me just share my. Okay, so you know the if question statement. So you had some. So let me just write it down. So let's say we have this event A that your battery functions over 10,000 miles, right? This is the question you are referring, right?
Yes, sir, this one.
B that your battery functions over, let's say, I think 20,000 miles, and event C be that it's working over 30,000 miles, right?
Yes, sir.
And we know individual probability as well, right? It's 0.8, it's 0.4, it's 0.1, right? Okay. So in which, okay, so let's say these are your, so this is your sample space. Okay, so how did you try to make it? What diagram did you got when you tried plotting it?
So this question I couldn't make it actually.
But you could have, like, why did you
I
approach
couldn't,
the,
sir, when I read the question, I couldn't do it. Then I gone through the solution, like what the teacher is explaining. But in that, I couldn't understand the Venn diagram itself. Like, I thought like 0.4 will extend, like if it is point A, then point B will cover A and B, but it is inside the A. But I was expecting like another 10,000 will be outside A.
okay.
Like I was thinking like point B will be the event like A and then plus B. But it is inside the A as per the lecture.
Okay.
Likewise, I was expecting C should be like A plus B plus C. Like C will not be inside B. I was thinking like the first 10,000 will be common and then 10,000 will be the extra. Likewise for C, first the 10,000 will be common for A and another 10,000 will be common for B and then another 10,000.
Okay, let's suppose this red region is event A. Okay.
Okay, A, yes.
So a battery functioning over 10,000 miles, right? Over
Yeah.
10,000 miles may or may not, go over 20,000 miles, right?
Yes.
So suppose pink is your event B. So it will go. Okay. So it cannot be
It
here.
should be within A, sir. Yeah.
It would be within it. So it cannot be outside here, right? If it haven't gone 10,000 miles.
Because 20,000 comes after when you finish 10,000, right? So we are already in the event A. After completing the event A, then only we can go into event B.
Yeah, that's I understand. But my question I couldn't understand is like first 10,000 within A. How about another 10,000? That is exceeding the A, right? That's what I'm not getting.
No. This is not like you don't have to go for miles. See, these are three events: event A, B, and C, right?
Okay.
So let's say this red region is that your battery will work over 10,000 miles, and this white region is that it won't, right? Now your next event is that it will work over 20,000 miles. So this pink region has to be within red, because if your battery could not work over 10,000 miles, how would it work over 20,000 miles? Right? So this pink region specify that this much region of red also satisfy event B. The remaining doesn't. And within white region, we cannot have pink region, because if our battery, white region is our battery is less than 10,000 miles, right? And this complete region is that it is greater than equal to 10,000 miles, right? So
Okay.
within this, I'm assuming this is the region which is greater than equal to 20,000 miles, which is my event B, right?
So you are taking it as greater than and equal to. I was taking it as a equal to only.
Even if you take it as greater than, it doesn't. Equal to, no, it's not equal to. It's greater than equal to.
Okay, so over 10,000 means we have to take it greater than equal to. If it is only 10,000, then we have to take it equal to. Then the Venn diagram will be totally different, right?
Yeah, then it would be different. So over means it's good going over 10,000 miles, greater than 10,000 miles.
Okay.
Okay, so now event C is it go over 30,000 miles. It means it have gone over 10,000. It has gone over 20,000. Now it should go over 30,000, right?
Now I
So
got it, sir.
it
Where
will
I
be,
was wrong.
so it would be this region inside this red
Yeah.
and pink.
Yes. And sir, if in case it is not over and it is just 10,000 mile and 20,000 miles, then how you would make the Venn diagram?
If it's exact the same, you're saying? If it is exact
Yeah,
10,000
in the
miles,
same question, yes, in the same question, if it is not mentioned over, like not over 10,000 miles, if it is mentioned just 10,000 miles
okay.
and B is 20,000, like just remove the over, then how will you make the diagram? I mean, Venn diagram?
In that case, it might, like, it
No,
depends,
it
right?
still
How
be the
many
same,
miles?
right?
No, it still won't be the same. It's
Yeah,
Because
it won't be
each
same.
no, the
it's
mileage. Okay, when we say 30,000 means, so we can come to 30,000 only after finishing 10,000 and 20,000, right? So
So
every
just,
time,
no.
so
She's saying
A
that
should be inside the B then. And then and A and B should be inside C, right? In that
no.
case.
If you're saying equal to, it means it exactly working for 10,000 miles, right? It's exactly working for 20,000. It's exactly working for 30,000.
Yeah, that's what I'm saying. It should
All
be
three
something
would
like
be disjoint events, right?
disjoint. But the battery is same, right?
But events can be disjoint, right? When you roll a die, okay. When you roll a die, you say when you roll a coin. So let's say event A is heads, event B is tails. Are this disjoint event or not?
No, this is disjoint. This is very much
Coin is same.
obvious. But if a battery, like
Yeah.
for
But
battery,
coin
I
is
think the
same.
battery will be okay, got it. Yes.
So my battery
It
will
will
either
be
work.
different cases because
Yeah.
this will be the different cases.
Yeah.
That's why it is disjoint. Now got it. Yes.
Okay. So okay. Anything else? Anyone?
Sir, my request for activity question 7, not tutorial 7, sir. It's activity questions in 7
Okay.
from second question onwards.
Second question onwards. Okay. How did you solve this one?
Which one, sir?
Second one.
No, I have not been able to solve second question onwards. I do not know how to get the answer.
But still, you might have approached this question, right?
Yes, but is it incorrect, sir?
Okay. Yeah, incorrect. So, like, what did you do? Right? You might, if you got incorrect answer, you might have done something and reached that answer, right?
Okay, you want to know how I solve this? Okay.
Yeah.
So here the probability that they are asking is for how they have served properly, right?
Yeah.
I multiplied both their serves probability that has been given there.
It means you multiply 0.6 and 0.7.
Yes.
But why so? What's the logic behind it?
Because both of them have, this is their probability of serving correctly.
Serving correctly, right? But only one of them would serve, right?
Yes.
Let me give you a hint on this. I think you can solve remaining might after that. Okay. Okay, so we have two players, right? Let's say player D and player R, right?
Yes.
And both are equally likely to serve, right?
Mm-hmm.
Equally likely to serve means
Both have equal chance.
yeah. So let's say that player D would serve its 50% chance and player R will serve its 50% chance, right?
Yes.
Okay. What is the chances of serving correctly if player D is serving?
That
Given
would be their percent. Yeah.
what is the chances of serving correctly if player R is serving? I think it's 0.6, right?
Yes.
So what are the probability that it is served correctly, right? So if you want to
Yes.
visualize it, it would be something like this. These are equally likely even this is player D and player R, right?
Yes.
This is your event C that it is correctly served.
Correct.
This region plus this region would give you the probability of C.
Yes.
What is blue region? Blue region is D intersection C, right? This light blue region.
Light blue region is?
D intersection C,
Yes.
and red region is
Intersection R.
R intersection C, right? So how can I find D intersection C now? I can write it as probability of C given D into probability of D.
Mm-hmm.
And second one, I can write it as C given R into probability of R by multiplication rule.
Mm-hmm.
Do I know probability of C given D?
That
Do I
is
know probability
0.7.
of D? Yeah, we know probability of C given R. We
Mm-hmm.
know probability of R. Plugging in, we can get probability of C, right?
Okay. But in this case, why do we have a plus instead of a multiplication, sir?
Because either D will serve or either R will serve, right?
Okay. Okay.
They're
Got
not
it.
serve.
Okay.
Both are not.
Thank you.
Yeah, just try the rest of the questions by this approach now. Okay, yeah. Anyone, anything else? Or shall we wrap up for today? Okay, we will end for today then. Thank you, everyone.
Thank you, sir.
Thank you, sir.
Thank you, sir.